Time to begin building our construct focus function. So first, let's declare it. And let's decide how many parameters we want to pass into it. So per each central point, we need to build it off of an image. And we need to decide where that central point lies. So that will be our x and y coordinate passed in as parameters. Now, again, the idea is to think about how we're going to represent this idea of grabbing the values relative to each central point. 3 above, left and right, and then 3 below. Now, this is a really key part of this algorithm. So the way I've approached it again is subject to just my own thinking. You may figure out how to do it in your own way, but I'm going to go ahead and represent those values like so. So for the row above, it's going to be represented like this. Let R1 is x minus 1. Similarly, row 2 would then be where that actual x coordinate lives, so there's no need to say a minus 1 on it. It is let x. Now, what do I mean by that? What I mean is that the x coordinate for 7 here is on 1 and not on 0, so x is already on that position. So if we wanted to describe something like what is to the right of it, or actually below it in this case, let's do R3, it would be x plus 1. Now, describing things above and below it, and we're going to do that relative to y. We're going to say, okay, let column 1 is equal to y minus 1. Let column 2, where the y coordinate exists, just be equal to y. Let column 3 be described as y plus 1. So through these values here, we have the description of points to be picked. And through these values, we can describe any given coordinate on a 3x3 grid, a 3x3 array. And that is what we will be doing next. So we first need to describe how we're going to be packaging the focus together. And then we're going to package it together in an array. We're going to call it let image internal equal to an empty array. And let's go ahead and let's describe that first row, and let's call it inner1. So the first row in what we're grabbing can be described like so. Image R1, and then C1 as the coordinate for that first position, 0, 0 on our 3x3 grid. Let's go ahead and copy this. So moving across the grid, just changing this to C2, and then this value here to C3 describes all of those topmost values right here. Row 1, column 1, 2, 3 equals 1, 1, and 1. Afterwards, what we want to do is we just want to go ahead and do an image internal push and that whole row in. And just like we've done this for our first row, we need to do this for the other two in our 3x3 grid for our focus grid. So I'm going to copy those out here. This will be called inner 2. And this here, the main difference being this time this will be row 2, because that's what we're trying to describe. And these all have to change as well. You can't just go and leave those hanging. And again, in a similar way, to describe this third most row, if we take our first example and we look at just a 3x3 array, which is what we're trying to do with our focus, this here needs to be changed to a 3 to describe each of those elements on the most bottom row. changing them all up. Okay, so once those are all there, we need to go ahead and we need to just say, all right, let's just return a value. Let's return our image internal because our function needs to provide something for the rest of our code to work with. We just finished up our function construct focus and scrolling back up to our make row function. The next thing we do after we construct a row or a focus and we build from that is we sum those blocks together. So we want to sum up each of the elements and then we want to perform that math operation where we condense it into one value. So that's what we're going to be building out now. And as we outlined it here as sum block, we're going to call it that. First step is to declare it. So function sum block. And sum block, we're going to say is only going to take in one of those internal image internals returned right here. And we're going to refer to that as a frame, like a frame of reference. Now for each of those frames, we can go ahead and we can address the rows individually as row 0, 1, and 2. So I will go ahead and use a reduce function to go ahead and sum up each of those rows individually. ES6 style fat arrow functions in this case. And we're going to call this, all has to be equal to something. So let row 1 equal to this. Just checking to make sure that everything is in there. Yeah, so we have that for one row, and we can go ahead and do this for the other ones too. So this is row 2 right here. Change that to a 1. This would be row 3 here. This would be a 2. Again, we're going by 0 indexing, which is why it's necessary to outline things like so. Clean this up just slightly. No, actually. All right, so we have row 1, row 2, row 3. Now we want to go ahead and sum the values of all of those. So row 1, row 2, row 3. So that would be the sum of all of those rows together, each of those elements. So we know in a 3 by 3 grid we have 9 pixels. So let's just go ahead and put this out here just for clarity. Again, you look here, there's 3, 6, and 9 in a 3 by 3 grid. And then we want to return math floor sum val number of pixels. All right, so what we've done here is we've looked at each of those rows individually. We've summed up the elements. Here we've taken all of those rows and made it a sum of all the elements in a 3 by 3 grid matrix. And then we divide it by 9 down here. And we take the math floor of it to do a downwards rounding on it. And then our function returns it. So here we've pretty much wrapped up the construction of what we need to do to build out our algorithm, our box blur, and it's just a matter of debugging and seeing how it works now. All right, so we're going to begin some debugging. First, let's just take a quick look of what we've built up here. So we've built a series of functions, helper functions to work through our array of arrays, a matrix, look at 3x3 grids and sum them. And we have a variety of simple tests, medium tests, and larger tests of different array sizes to see how our algorithm works. So I'm going to go ahead and run the simple test in here. And down here in the console in the output, you can see that we get the result we want. Now, if I go ahead and I change this to the medium, you will see that I do not get the values that I want. I was expecting 30, 40, and I got 18 and 9. So let's scroll back up and do some debugging and see what may be going on. So it most likely has something to do with the summing, but then I can also scroll up and see where I'm getting the values for those things to be summed up. Where is it coming from? So it's coming from the rows. So in each of these rows now, I can right away see that I've repeated the same thing sloppily just from my copy and pasting. So inner one and inner one should be pushed in. But here I have inner two, which where I was saving all these values, and that's what needs to be passed in here. And likewise here, this should be inner three and not inner one. Make sure it's capitalized. And now we do get what we want. We do get 30 and 40 down in the console. And let's run our large test. And we also get what we were looking for. And now let's go ahead and let's copy all of this and throw it into our code signal. So we're going to do a quick recap of the box blur question, the box blur algorithm that we just solved, implemented it in code signal, everything's working. We have it here. So to summarize, we have some helper functions. We have a make row function. We have a construct focus based off of a position, a central point. We have a sum block function, which sums each of those focus sections and performs a math calculation on it. And then all of that gets worked through our box blur function, which moves our positional focus around until it gets to the end of our array. So that is how our box blur algorithm works. That's how I implemented it in code signal, and I hope that helps. Take care.